Hey everybody, Mr. Ellinger here. We're going to go over the integration. It was day 15, integration technique file. And so we're going to go over it, but I just want to say something before we do. First, the tricky thing to notice on this is this whole problem they have that they can't ask questions in sort of basic fundamental ways that they could normally, because they could take the calculator out of your hands and make sure you could do an integral. So if we're talking about an integration technique, we would say integrate this function here that we have. If they just give you a function, say integrate it, the problem is that people can just look it up on their computer, and that's what they want to avoid. So they have to ask questions in slightly different ways, and we'll show you how they do that. And once you get used to it a little bit, once I started reading them and going, oh, okay, I'm starting to get this a little bit, then they become more manageable. And we'll show you some of the things that you can do in order to be able to do that. That's the plan. Let's go over the problems now and see what we see. So here's the sheet for your response practice problems. Yes, and so we're going to go over these right now. Take a second, just familiarize yourself with the problems. Okay, so let's take a look at this first problem here. So they give you a bunch of information, and I know that all this stuff that they give here is going to be stuff that I'm going to need to do the problem, but I'm just not going to deal with it yet, because I don't know what I'm going to need that stuff for. So I'm going to go to the first problem. What do I got? I've got a 2x, I've got 2x, and I've got f prime of x. So I've got two functions there. There's no chain rule connection that I can use. So integration by parts is the way to go, because I can drop that 2x down to a 2. So I'm going to make u equal to 2x, and du is 2 dx, and there's u, and then dv is f prime of x. Woo! I'm gonna need to plug in, and before I do that, dx, and v is f of x. I'll go grab my cord, and we'll plug this stuff in and work this thing out. You could pause it right now and try it yourself with this substitution. That's better. So I've got, so this is the integral of u dv, right? And so remember that that's equal to uv minus the integral of v du. So we just plug the stuff in. So we've got 2x f of x, I'm sorry, not 2x f of x. What am I saying? Used. Oh, I know, I am saying that. 2x, sorry, a little confusion. 2x f of x. And remember that that's going to be evaluated also from 0 to 4. So we're going to have to evaluate that from 0 to 4. And then minus the integral of v du. So v du, which I'll put the 2 on the outside because I know I'm going to put it there eventually. 0 to 4 of f of x dx. And so notice what happens by writing the problem in this way and not just giving you a normal integration by parts problem. They're making it so that there's no function here that you can plug into the calculator because you don't have a function for f of x. And so this forces you just to be able to do it yourself. So this is going to be 8 f of 4, and then minus, I'd plug 0 in, but that would give me 0. And then minus, yeah, I know I need to get better at writing this. And so the integral from 0 to 4 of f of x. Well, I'm hoping that they've given me enough information that I can figure it out. And, well, they just gave it to me. So that's what they're doing, is they're giving us this stuff in the problem without giving you a function. And that way you're forced to be able to understand what to do and just do it yourself here. Really, it's like not knowing the antiderivative of things isn't as important as knowing the basic technique on how to do it. So that'd be 2 and times 8, and f of 4, what's f of 4? F of 4 is 3, so this is 24 minus 2 times 8, which is 8. That's what I got before. That's correct. I've got I did these before to make sure that I could do them efficiently. I wouldn't make any wrong steps here. Now this one is different. So this one is has got a chain rule aspect to it, because I go, okay, I've got two functions, but I've got an inside and an outside, and I can see the derivatives match up and stuff. So I'm gonna do this. But there's one other thing I noticed. I started this problem for a bit, and then I noticed that the integral was from 1 to 2, and that's not very helpful in this problem. So I was like, oh, okay, that's kind of an issue. I can't integrate this thing from 1 to 2 because I won't know about f. But I was like, oh, wait a minute. what if we actually do a U-substitution for this and change the bounds? That might make the bounds nicer numbers, and then I'll be able to work it out. So there might be another way to do it, but once I saw that, this made a lot of sense to me. So I said, let's make u equal to x squared minus 1, and du is 2x dx, right? So this part of it ends up, the substitution part ends up being the same as if you did chain rule. It wouldn't make a difference. So it's the integral of, and there'd be a 1/2, because I'd have to solve for x dx. I have those parts. So I'd have 1/2 and f of x squared minus 1. So that's just f of u du. But the key to it is to, let's leave it in u and let's change the bounds here. If x is equal to 1, remember this has to do with x. If x is equal to 1, looking over at my formula, u is equal to 0. And if x is equal to 2, u is equal to 3. Woo! And I go, oh, okay, this is working now, and I can solve this one by making this one. Sorry, that 3 was just too embarrassing for me. I have to have some sense of self-respect here and put a 3 there. So now I can do this one because they gave me that information. Wait, no, they didn't give me that information. They gave me the integral from 0 to 4. So the integral from 0 to 4, and they gave me the integral from 4 to 3, right? And so I need the integral from 0 to 3. I can add these together. See how we're doing basic integration rules. It's just they're clouding them a little bit just to make them cheat proof. It's basically. And so the integral from 0 to 4 is 8, right? And the integral from 4 to 3 is -3. So that means the integral from 0 to 3 is 5, right? Yep, 5. Okay, just checking my answer, making sure. I did these last night and I didn't have time to record them, and I want to make sure, like, okay, my brain's still working on this one. So I can pull the 1/2 in front. And then the integral from 0 to 3 of f of u is, from what we saw before, 8 minus 3 is 5. So it's 1/2 times 5, which is 2.5. Yeah. All right. Next one. What do I got? I got a cosine. I got sine. Ooh, this looks very chain rule-ish. Feeling good about it. Again, though, I can't use my computer to do this for me, but it's a pretty easy one to do with Lindstrom. And in fact, I could. Actually, but this shows up a few times. I've seen this thing happen on a few problems, so this is a good one to see. So they've got f prime of x there and cosine x. So there's my inside. There's my derivative of the inside. Ooh, it's great. I love it. And so I just need to do the antiderivative of the outside. So by giving you, rather than giving you a function there, rather than saying like square root, they just call it f prime. And so the antiderivative of this is just f. Right? So it's just going from f prime to f, taking care of the chain rule for the stuff in the middle. So it's just f of, leave the inside alone. You know, if there was something like square root there, you would have antiderivativized that, and then you'd be able to plug your numbers in. So they're just kind of shifting it just a little bit in order to make it safe. Okay, I'll stop hitting that one. I've hit that way too hard. Evaluate this from 0 to pi over 2. So it's f of sine of pi over 2. So that's f of 1 minus, plug in 0, f of 0. And f of 1 is 2 from the diagram above, and f of 0 is 3. And so the answer is -1, and that's correct. If it is known that the integral from 3 to infinity, let me get this one in front of me. Yeah, okay. The integral from 3 to infinity of f of x dx is 9. Find the value of a. Okay, so what is this? All right, this was this thing where they said for x greater than 5, you can use this function. And we need to integrate it from 3 to infinity. All right, let's take a look at this thing. And actually, I should expand things a bit so I've got a little more space. Okay, so what do we got? Okay, so it's the integral from, we want the integral from 3 to infinity, right? And I can integrate it from 5 to infinity using the function that they just gave me that works for 5 to infinity. And then I just need to know, what is the integral from 3 to 5? Well, they told me, or I worked out already, that, oh no, they told me. They told me the integral from 4 to 3 is -3. That means the integral from 3 to 4 is 3. The integral from there to there has to be 3 because it's just going the opposite direction. And then the integral from 4 to 5, I just need to count boxes. 1, 2, 3, and then that's 2 by 1, so that's 1. So this area is 4. Okay, I'll show you how we use this. So I need the integral from 3 to infinity, and I'm just going to do the integral from 3 to 4 of f of x dx plus the integral from 4 to 5 of f of x dx plus the integral from 5 to infinity of f of x dx. All of that is equal to the integral from 3 to infinity, to infinity, of f of x dx. And all this is telling me is, since this one is 9, and I've already worked out above that this is 3 and this is 4, that means that I need to figure out what value of a would make this integral equal to 2. Just subtract stuff over, and so you get the integral of f of x dx equals 2. And so now I need to figure out what would be that value that would make that work. I don't have enough space here, so I'm just going to grab a blank Word page and do it here. So I need the integral of, what was that function again? Let's go up to it. 4 over x minus a squared. Got it. 4 over x minus a squared from 5 to infinity has to be equal, dx has to be equal to 2. And I'm being asked to find the value of a that makes this true. All right, let's do this. Remember to do indefinite integrals. So we've run into parts. We've run into chain rule, basic chain rule stuff. We've run into now indefinite integrals. The only really big one that we haven't seen so far is we haven't seen partial fractions, but it's got to be coming, right? So this is the limit as b goes to infinity of this thing with a b in it instead. I could do this in one step, I think. So that's x minus a to the negative 2. So bump it up. So it'd be x minus a to the negative 1 with a 4 in front has to be equal to 2 if I evaluate this from 5 to b. Well, make sure you do the limits. Don't plug in infinity there or something like that. They'll mark you off for that. I can divide both sides by 4 just to get rid of it. I don't like that. So it's 1 over x minus a evaluated from 5 to b is 1/2. Right? Let's plug in b. So if we plug in x being b, yeah. It's funny. For a moment I thought this was going to be really hard and involve a lot of algebra, and it's because I forgot the exact same thing I forgot last night when I was looking at this. 5 minus a equals 1/2. But remember, this is the limit as b goes to infinity. This is the limit as b goes to infinity. So this thing right here is just 0. That's what was freaking me out last night. But I was like, wait a minute. Don't forget about the limit. And then it's a piece of cake. So I just need... Yep, I got a little bit of an issue. Oh, yeah, I do. Spotted it a little too late. I forgot to put the negative in front. That makes it work. And so now I solve this plus. So I need this limit is 0. So 1 over 5 minus a equals 1/2. And so a equals 3. And that's the correct answer. Yep. So I got. All right. So that's the first one. I'll try to be a little more step by step on the rest of them. But I thought talking about why the problems are written the way they are might help you. And then I'm hoping some of the steps, some of the techniques that we've done on this one, they'll apply later too. So that's that one. Recording another one. Enjoy. Stop.